All right, good evening. I'm going to be talking about finding the inverse of an exponential function and of a log function tonight. All right, the first thing that I want to remind you is that exponential functions and log functions are inverses of each other. What that means is when I'm finding the inverse of an exponential function, my answer better be a log function. And if when I'm finding the inverse of a log function, my final answer better be an exponential function. All right, let's take a look at these two examples that I've got written down below. I want to find the inverse of each one of these. Let's start with the first equation, the exponential. Well, don't forget that for all functions, when I start off by finding the inverse, the very first thing is I simply switch the letter x with the letter y. I get x equals 3 times 2 to the y minus 1 power. Now, to rewrite this in exponential or log form, the very first thing I have to do for that is I have to isolate my exponential expression. That exponential expression in this problem is a 2 to the y minus 1 power. I need to isolate him. Well, to do that, all I need to do is divide both sides by 3, and by doing that, I get x over 3 equals 2 to the y minus 1 power. Now that my exponential is alone, I can now change this from exponential form to log form. When I do that, I get log base 2, because that's the base of my exponential, of x over 3, that was the old answer, that becomes the argument of my new log, equals y minus 1. Now to get y alone, I just add the 1 across. I get y equals log base 2 of x over 3 plus 1. And that is the inverse of the original exponential function. Now, before I move on to the next problem, we want to analyze the domain and the range of the original function and the domain and the range of the inverse. Well, we say that for the domain of every exponential, because there's no limit on what I'm allowed to plug in for an exponent, the domain would be all real numbers. The range for an exponential, however, is not all real numbers. Again, because I'm producing some type of positive value multiplied by 3 in this case, it is impossible for my y value to ever be less than or equal to 0. So my range is y has to be greater than 0. All right, now take a look at the domain and the range of the log. Now for the domain of a log, we know that for arguments, in this case x over 3, arguments can never be negative or 0. Well, if you look at this x divided by 3, what that means is my domain would have to be x has to be greater than 0, because anything 0 or less would give me a negative argument. My range in this case would be all real numbers, because no matter what I plug in for x, I can get any real number out for y. Now, again, taking a look at the domain and the range of the exponential versus the domain and the range of the log, if we look at those, let me just do a little bit of minimizing here to pull these together so we can see a little bit. Okay. When I look at these compared to each other, the domain and the range of the original versus the domain and the range of the new log equation, notice that since the x's and the y switched, didn't your domains and ranges just switch places with each other? Which we know has to happen when we find inverses. Okay, let's move to the next problem. In example B, I've got y equals 2 times log base 3 of x plus 4. That's a log function. So the first thing I have to do with him is switch the letter x with y. I get x equals 2 log base 3 of y plus 4. Now again, I need to isolate the log expression so that I can rewrite this problem in exponential form. You cannot write from one form to the other unless the log expression is alone or the exponential expression is alone. Okay, so take a look at this. To get this log expression alone, I would just divide both sides by 2, so I get x over 2 equals log base 3 of y plus 4. Now that my log is alone, I just rewrite this in exponential form. This would give me 3 to the x over 2 power, oops, I don't know why that's highlighted, x over 2 power equals y plus 4. From here, just simply subtract the 4 across, giving me y equals 3 to the x over 2 power, and then minus 4. That is the inverse of the original function. Again, looking at both functions at the same time, their domains and their ranges compared to each other. Let's take a look here. If I shrink this down a little bit so there's some room to think and work. The domain of the original function, since he's a log, again, my domain, the argument can't be negative, so x has to be greater than negative 4, right? Can't be 0 as well. The range for a log is all real numbers. Now look at my exponential. We know the domain of an exponential is all real numbers because there's no limit on what I can use as an exponent. But my range, because I can't get this part right here, remember that the exponential expression, that's impossible to ever get anything, it can't become 0. So I know that that has to be some positive value. Well, if I take any positive value and subtract 4 from that, I know that the answer would have to be at least a little bit above negative 4. Because of that, my range would be y must be greater than negative 4. Again, comparing these domains and ranges with these domains and ranges, notice that they just switch places with each other as they should. Okay, well that's it for inverse functions, exponentials, and logs. We'll talk to you tomorrow.